It's not. Whoops. So you know that the general rule of adding and subtracting any fraction is that they have to have common denominators. What we will find is basically the least common multiple of the denominators and then convert. You always want to focus on the larger of the two denominators because you can ask yourself right away, is that 12 a multiple of 3? If you counted by 3s, would you get to 12? So we're just going to use that 12. So what I'll do is I'll convert the 1/3 to 12ths. We'll look at the denominator. To get from 3 to 12, we had to multiply by 4. So multiply the top by 4. So now we just add 5/12 and 4/12 is 9/12. Remember, you just add the numerators. Do not add the denominators. 9/12 has to be simplified, Kennedy, right? So they both have 3 in common and 3/4. Okay. That's a little bit dark. Now, they'll also ask you to add and subtract mixed numbers, which essentially you separate the two. You treat the fraction portion first, and then you move on to the whole numbers. Okay? You've been adding whole numbers forever. That much isn't really that different. So we need to find common denominator between a 9 and a 6. We'll look at our larger, the 9. 9 is not a multiple of 6, but my next multiple of 9 is 18. Does 18 work for 6? Okay, now you don't always have to pick the smallest denominator that they have in common, but it helps because hopefully it limits how much simplifying you actually have to do. So 9 times 2 is 18, 5 times 2 would give us 10, and 6 times 3, and 1 times 3, right? So 10 18ths plus the 3 18ths is 13 18ths, and then the 3 and the 2, 5 and 13 18ths. Okay. I'll give you one to try. Give you a couple of tries before we start getting it. Let's do 1/12 and 3/16. And 5 and 1/4 plus 1 and 2/5. Okay, now with some of these, it might be in your best interest to write them vertically. It might be easier to see as opposed to writing them sideways. So when I look at the 16, I think of the multiples. 16 doesn't work for 12. The next multiple of 16 is 32. 32 doesn't work for 12. So I need to think of the next multiple up from 32 is 48. Does that work for both? So we're going to work with 48ths. 12 times 4, so 1 times 4. And 16 times 3, so 3 times 3, 9. 4 plus 9, 13 over 48. Over here, between a 5 and a 4, what's the first thing that jumps out at you? 20, which also happens to be your LCD. So times 5 is 5, times 4 is 8. 5 plus 8, and 6. Okay. We're going to both. Good. Well, I asked. I wanted to make sure. Right. Negative 2/3 plus a 1/4. Okay. Now, however we want to do it, we want to even just put it like this, like I said, just as long as you know what we're doing. Don't get thrown off by the positive and negative stuff until we actually convert. I mean, the first thing we got to do is convert them. Then we can worry about the, integers and what direction we're moving on a number line and all that. But go through this process first. 3 and 4, I'm thinking probably 12. Times 4 is 8. Negative 8. Times 3 is 3. Okay? Now, essentially, what is it that we're doing? Because when we add or subtract, really, once we get common denominators, we're really only focusing on what? Right. So I have on the top, I have what, Africa? So a negative 8 plus a 3 negative 8 plus a 3 no, if you're starting here at negative 8, you add, you always go to the right. Good. So negative 5 over what? Yes. Now remember, this first integer is our what? Starting point. Okay? Then from there, so once I'm on my number line, once I'm at that negative 8, okay, once I'm here, then when I add 3, remember when I add, I go this way. So I go the 3 places. Okay? Okay? So don't confuse it. If the fraction works the same way as if we were just adding and subtracting regular integers. Okay? Okay, here, try this one. Negative 1/4 plus 1/8. Okay, so negative 1/4 plus a 1/8. Yes, you are absolutely correct. If I don't have to switch, then I don't. But I do here. Times 2 is a negative 2, right? So a negative 2 plus 1, negative 1 over 8. Okay? What? Anyone have an idea what I was going to say? What? Well, here's what I was thinking. Could I have rearranged the problem at all? Because I just have to make sure that if I do move anything, I move it with the sign that's in front of it. So what is this really? It's 1/8 minus 1/4. Okay. Then you would have had 1 minus 2, which would have put you at negative 1 again. So, I mean, sometimes that may make it a little bit clearer for you. Sometimes it may make it a little more difficult. But I'm trying to see if there's one. Oh, let's try one of these. Here's what you call. A negative 4 and 3/5 plus 7 and 4/15. What? So common denominator, 15. So that's a 4 times 3. That's going to make it a. Right? So a negative 9 plus a 4. Maybe this is one, hold on. Maybe this is one that we switch. 7 and 4/15 minus what? 4 and 3/5? Because there's going to be somewhat of a problem here, I think. If we switch when we can, we may be able to sniff out the problem a little bit easier. So 15, it's going to keep that, right? Times 3 is 9. What's the problem? I cannot take away 9 if I only have 4. So what we need to do is we're going to borrow one whole from our whole number department. What's our denominator? 15. Okay. So if I took one whole, how many 15ths is that? How many 15ths is one whole? 15, right? 15 15ths equals one whole. So notice how I went from 7 to 6. I took one whole, and I'm going to bring it over. I'm just going to transfer it over to the fraction column. Okay? So if I already have 4 there, and I bring over 15, how many do I now have? 19. I'm taking that one whole, putting it in fraction form. Yeah. I'm just trying to show you a better way. Because I don't know if we would have got it. Well, this, Africa, I guarantee this is, you've learned this from 6th grade on. Okay.
Wait, so why can't you subtract?
Right, but then, just bear with me. Okay. So 19 minus 9 is what? 6 minus 4 is 2. 10 15ths in simplest form. 2 and 2/3. Did you have that? Okay. I think that this way, because now we get back here, right? -9 plus the 4. It's not really helping us, is it? So I would switch in that case. When you can, I would. Let's see if we get another one. This one? Yeah. Because this turned into 19, Mia. Because I brought 15 15ths over to the 4 15ths. 15 plus 4 is 19. Then take the 19, subtract 9, you get the 10. Let's do this. We'll revisit the mixed numbers. Let me just give you some problems that have just regular fractions. Page 234, 13 to 19. 7 problems.